Welcome to your ultimate guide for cracking Java interviews in 2026. Whether you're a fresh graduate or an experienced developer, preparing for a Java interview can be daunting. This video will walk you through the top 50 Java interview questions, covering everything from core concepts to advanced features. We'll break down each topic, explain the reasoning behind the answers, and provide practical tips to help you stand out. Let's get started on your journey to Java interview mastery and boost your confidence for any technical challenge ahead. Foundation of any Java interview starts with core Java basics. Interviewers expect you to understand the differences between JDK, JRE, and JVM, as well as how Java achieves platform independence. Knowing these basics not only helps you answer direct questions, but also demonstrates your grasp of how Java applications run and are developed. We'll begin by exploring these essential concepts, setting the stage for more advanced topics later in the interview. JVM, or Java Virtual Machine, is the runtime engine that executes Java bytecode and provides platform independence. The JRE, or Java Runtime Environment, includes the JVM plus standard class libraries needed to run Java applications. The JDK, or Java Development Kit, contains everything in the JRE plus development tools like the compiler and debugger. Remember, end users need the JRE, while developers require the JDK. Understanding these differences is crucial for both development and troubleshooting. In Java, the == operator compares object references, meaning it checks if two variables point to the same memory address. The equals method, on the other hand, compares the actual content of objects, as defined by the class's implementation. For example, two different string objects with the same value will return false with ==, but true with equals. Always use equals for object and string comparison, and reserve == for primitives or intentional reference checks. Java has 8 primitive data types: byte, short, int, long, float, double, char, and boolean. These types are the building blocks for data manipulation in Java and are stored directly in memory, making them fast and efficient. Understanding these types is essential, as they are frequently used in both coding and interview questions. Mastery of primitives helps you write optimized code and avoid common pitfalls related to type conversions and memory usage. Autoboxing is Java's feature that automatically converts a primitive type to its corresponding wrapper class, such as int to integer. Unboxing is the reverse process, converting a wrapper object back to its primitive type. This makes working with collections and generics easier, as they require objects rather than primitives. However, be cautious. Unboxing a null wrapper will throw a NullPointerException at runtime, so always check for nulls before unboxing. String pool is a special memory region in the Java heap where string literals are stored. When you create a string literal, Java checks if an identical string already exists in the pool. If it does, it reuses the reference, saving memory and improving performance. Creating a new string object with new always allocates a new object on the heap, even if the value is the same. This distinction is important for both memory management and object comparison in Java. Java uses the keywords final, finally, and finalize for different purposes. Final is used to declare constants, prevent method overriding, or stop inheritance. Finally is a block and exception handling that always executes after try-catch, ensuring resources are cleaned up. Finalize is a method called by the garbage collector before destroying an object, but it's deprecated in Java 9 and later. Knowing when and how to use each is a common interview topic. In Java, string is immutable, meaning its value cannot be changed after creation. String builder and string buffer are mutable, allowing you to modify their contents. String builder is faster and preferred in single-threaded environments, while string buffer is thread-safe and suitable for multi-threaded scenarios. Understanding the differences helps you choose the right class for performance and thread safety in your application. Static variables belong to the class itself and are shared across all instances, meaning there's only one copy in memory. Instance variables, on the other hand, belong to each object, so every instance has its own copy. This distinction is crucial for understanding how data is stored and accessed in Java, especially when dealing with memory management and object-oriented design. Yes, you can overload the main method in Java just like any other method. However, the JVM will only call the standard public static void main string args as the entry point. Overloaded versions can be called explicitly within your code, but they won't serve as the program's starting point. This is a common interview question to test your understanding of method overloading and the Java application lifecycle. Varargs, or variable arguments, allow a method to accept 0 or more arguments of the same type. Internally, varargs are treated as arrays. This feature simplifies method signatures and makes your code more flexible. Remember, varargs must be the last parameter in a method signature, and only one varargs parameter is allowed per method. Object-oriented programming in Java is built on 4 pillars: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation binds data and methods together, hiding internal state. Abstraction hides implementation complexity, exposing only what's necessary. Inheritance allows a child class to inherit properties from a parent class. Polymorphism enables one interface to have multiple implementations, achieved through method overloading and overriding. Method overloading occurs when 2 or more methods in the same class have the same name but different parameter lists. Method overriding happens when a subclass provides a specific implementation for a method already defined in its superclass. Overloading is resolved at compile time, while overriding is determined at runtime. This distinction is fundamental in Java's approach to polymorphism. An abstract class can have both abstract and concrete methods, and is used when classes share a common base. An interface, on the other hand, defines a contract that unrelated classes can implement. Use an abstract class for shared code and an interface for defining capabilities across different classes. This is a key concept in designing flexible and maintainable Java applications. This keyword refers to the current class instance, allowing access to the object's fields and methods. The super keyword refers to the parent class, enabling access to parent class fields and methods. This distinction is especially important when dealing with inheritance and method overriding, as it clarifies which class's members are being accessed. Java does not support multiple inheritance through classes to avoid ambiguity, known as the diamond problem. However, Java allows multiple inheritance through interfaces. A class can implement multiple interfaces, combining their capabilities without the complexity of multiple class inheritance. This approach provides flexibility and avoids common pitfalls. Constructor is a special method used to initialize objects in Java. It shares the class name and has no return type. Constructors can be private, which is useful in patterns like singleton, factory methods, or utility classes where you want to control or restrict object creation. This is a common interview question to test your understanding of object instantiation and design patterns. A shallow copy copies an object's field values, but for reference types, only the reference is copied. Both the original and the copy point to the same object in memory. A deep copy, on the other hand, recursively copies all referenced objects, ensuring that changes to the copy do not affect the original. This distinction is vital for understanding object cloning and memory management in Java. The instanceof operator checks whether an object is an instance of a specific class or implements a specific interface. It returns true or false, helping you write type-safe code. Java 16 introduced pattern matching for instanceof, which streamlines type checks and casting, making your code cleaner and less error-prone. A marker interface is an empty interface with no methods or fields, used to signal metadata to the JVM or frameworks. Examples include serializable, clonable, and remote. Implementing a marker interface tells the JVM or libraries that your class has a specific capability, such as being serializable or clonable. Inheritance models an is, a relationship, such as a dog is an animal. Composition models a has a relationship, like a car has an engine. Prefer composition over inheritance for greater flexibility and looser coupling, as inheritance can create tight dependencies between parent and child classes. The Java Collections Framework JCF is a unified architecture for representing and manipulating groups of objects. It includes interfaces like list, set, queue, and map, as well as implementations such as ArrayList, HashSet, and HashMap. The framework also provides algorithms for sorting, searching, and shuffling collections, making it a powerful tool for managing data in Java. ArrayList and LinkedList are 2 common implementations of the list interface. ArrayList provides fast random access and is backed by a dynamic array, making it efficient for read-heavy operations. LinkedList, on the other hand, is better for frequent insertions and deletions, as it uses a doubly linked list structure. Understanding their differences helps you choose the right collection for your use case. HashMap and Hashtable are both key-value data structures, but HashMap is not synchronized and allows null keys and values, making it faster for most use cases. Hashtable is synchronized and thread-safe, but generally slower. In modern code, prefer concurrent HashMap for thread-safe operations instead of Hashtable. HashSet is an unordered collection that does not allow duplicates and offers fast operations. Linked HashSet maintains insertion order, while TreeSet stores elements in sorted order. Each set type serves different needs, so choose based on whether you need order, sorting, or performance. HashMap uses an array of buckets to store key-value pairs. Java computes the hash code of the key and maps it to a bucket index. If a collision occurs, entries are chained in a linked list or stored in a red-black tree for efficiency. HashMap resizes automatically when the load factor threshold is exceeded, ensuring good performance even as the map grows. Comparable is an interface that allows objects to be compared based on their natural order, typically by implementing the comparator method. Comparator is a separate interface used to define custom comparison logic, often passed as an argument to sorting methods. Use comparable for default ordering and comparator for flexible, external sorting. Concurrent hashmap is a thread-safe variant of hashmap designed for high concurrency. Unlike hashtable, it does not lock the entire map. Instead, it uses segment-level locking or fine-grained synchronization, allowing multiple threads to read and write concurrently with minimal contention. This makes it ideal for multi-threaded applications. Generics enable classes, interfaces, and methods to operate on type parameters, providing type safety at compile time and eliminating the need for explicit casting. This feature makes your code more robust and easier to maintain, as errors are caught early during compilation. Checked exceptions are checked at compile time, requiring you to handle them explicitly. Examples include I/O exception and SQL exception. Unchecked exceptions, such as NullPointerException and array index out of bounds exception, are not checked at compile time. Errors like out-of-memory error are serious JVM-level issues and should not be caught. The throw keyword is used to explicitly throw an exception inside a method, while throws is used in a method signature to declare that the method may throw one or more exceptions. This distinction is important for writing robust and maintainable exception handling code. The finally block always executes after try-catch, even if an exception is thrown or a return statement is encountered. It's commonly used for cleanup tasks like closing streams or releasing resources. However, it does not execute if system exit is called or if the JVM crashes. Introduced in Java 7, try with resources automatically closes resources that implement auto-closable at the end of the try block. This feature eliminates the need for a finally block to close resources, making your code cleaner and less error-prone. A process is an independent program in execution with its own memory space. A thread is the smallest unit of execution within a process, sharing the same memory but having its own stack. Understanding this distinction is key for writing efficient multi-threaded Java applications. There are several ways to create threads in Java: by extending the thread class, implementing the runnable interface, or using callable with executor service. Prefer runnable or callable for flexibility, as it allows your class to inherit from other classes and supports advanced concurrency features. Calling start creates a new OS-level thread and then calls run in that new thread. Calling run directly just executes the method in the current thread without creating a new thread. This distinction is crucial for understanding how Java manages concurrency. Synchronization ensures that only one thread can access a critical section at a time, preventing race conditions. You can synchronize entire methods or specific blocks of code. Proper synchronization is essential for writing thread-safe Java applications. A deadlock occurs when two or more threads are each waiting for a lock held by the other, creating a circular dependency. Prevent deadlocks by always acquiring locks in a consistent order, using timeout-based locking, minimizing synchronized blocks, and leveraging higher-level concurrency utilities. Wait, sleep, and yield are methods for controlling thread execution. Wait releases the lock and waits for notification. Sleep pauses the thread for a specified time without releasing the lock, and yield hints to the scheduler that the current thread is willing to yield its current use of the CPU. Understanding these methods is essential for effective thread management. The volatile keyword ensures that a variable's value is always read from and written to main memory, not from a CPU cache. This guarantees visibility across threads, but does not ensure atomicity. For compound operations, use atomic integer or synchronized blocks. The executor framework provides a higher-level replacement for managing threads directly. It includes executor service for managing thread pools, executors for creating common pool types, and future for handling asynchronous results. Completable future, introduced in Java 8, enables non-blocking workflows. Lambda expressions, introduced in Java 8, provide a concise way to represent anonymous functions. They simplify code, especially when working with functional interfaces and collections. Syntax: parameters, expression or parameters, statements. A functional interface has exactly one abstract method and can be annotated with that functional interface. Examples include runnable and comparator. Functional interfaces are the foundation for Lambda expressions and method references in Java. The Stream API, introduced in Java 8, enables functional-style processing of collections. Streams are lazy, non-mutating, and can be sequential or parallel. Key operations include filter, map, sorted, collect, and reduce, making data processing more expressive and concise. Optional is a container object that may or may not hold a non-null value. It's designed to avoid NullPointerException and make null handling explicit. Use methods like filter, map, and or else to work with optional values safely. Java 8 introduced default and static methods in interfaces. Default methods provide a default implementation, allowing backward-compatible additions. Static methods are utility methods tied to the interface itself, not its implementations. This feature enhances interface flexibility. Method references are a shorthand for Lambda expressions that call a single existing method. They make your code more concise and readable, especially when working with streams and functional interfaces. The JVM manages several memory regions: heap for objects and class variables, stack for method frames and local variables, method area for class metadata, PC register for current instruction, and native method stack for native calls. Understanding these areas is crucial for optimizing performance and troubleshooting memory issues. Garbage collection (GC) is the automatic process of reclaiming heap memory used by objects that are no longer reachable. Java provides several collectors, including serial, parallel, G1, and ZGC, each optimized for different scenarios. Understanding GC helps you write efficient and reliable Java applications. Stack memory is used for method frames, local variables, and partial results, with one stack per thread. Heap memory stores all object instances and class variables, shared across threads. Knowing the difference helps you manage memory efficiently and avoid common errors like stack overflow error. Stack overflow error occurs when a thread's call stack exceeds its maximum depth, usually due to unbounded recursion. Always ensure recursive methods have a proper base case to prevent this error and keep your application stable. To succeed in your Java interview, focus on understanding the why behind each concept, not just memorizing answers. Practice coding on paper or a whiteboard, know your time complexities for collections, and be honest if you don't know something. Review Java 8 Plus features as they are standard in most codebases. Good luck on your interview journey.